Hi everyone. Now in this video we are going to see how to construct or draw an ellipse in a parallelogram, means ellipse in a parallelogram method. In the previous video we saw how to construct ellipse in a rectangle. Now we will see in the parallelogram method. You can see the question. The sides of a parallelogram are 120 mm and 80 mm, as well as the included angle between them is 75 degrees. These sides of parallelograms are 120 mm and 80 mm are nothing but called as conjugate diameters. These two lengths are called as conjugate diameters, not the major axis, not the minor axis. Always for the parallelogram, whatever the lengths we are seeing, it should be called as conjugate diameters, and then angle also they give. So first, how to construct, we can see the steps here. First one, construct a parallelogram with the given lengths of conjugate diameters and with the given included angle. Okay, now let's see. Take a line command L. The longest one is, okay, switch on the, activate this one, 120, and then vertical one 80 mm length, but whereas angle 75 degrees. Right now on the screen it is showing 90 degrees. Press tab and enter 75 degrees. Perfect. And then again 120. Next type C, which means close C, and enter. See, perfectly we prepared we drawn a parallelogram. Let's see DAN, dimension angular, to check whether we made the correct angle or not. Okay, it's not so visible. Let's increase the text by using the dimension style, DST, enter, modify primary units. Let me take it as 0.00, otherwise 0 is sufficient, as well as symbols and arrows 3. Text height, let me take it as 5. Okay, close. Perfect. See, okay, DLI, dimension linear, for this one 120 mm. Nice. DAL for inclined line. Perfect. 80 mm. Perfectly we constructed a parallelogram. Okay, the next step is that second one, join the midpoints of opposite sides. Okay, this side and this one, opposite side, and this one and this one. So what I am going to do, take a line, and this is the midpoint, join to this midpoint. Okay, now again line command, this midpoint to this midpoint. Perfectly we finished it. Next one, name the axis as AB and CD and parallelogram as EFGH. As of now, as I said, these are called as conjugate diameters. DT, this one I am taking it as 60. Okay, please name it as A, and then B, and this one as C, and this one as D, and this is the center of the ellipse O. Okay, done. And now we have to divide the OA and AE into equal parts. You can see that OA and AE. Okay, let us mark this parallelogram also. This one as E, and this one as F, and this one as G, and this one as H. Perfect. EFGH also. Now I need to divide this AO and AE into equal parts. What I am going to do is that it's a single entity. I need to break at this point, BR, bracket point, select this one, and I am selecting the bracket point. Finished. Now here also I need to break BR, bracket point, select this one. Nice. Perfectly I made it. Now what I am going to do is that div, divide. Select this object and divide into 3 equal parts. Enough. The same I am going to do here. div, divide. Select this one, 3 parts. Nice. Now let me mark this one here with the 3 0 1 and 2, and this one has 1 dash and this one has 2 dash. Enough. Mark the points and OA as 1 2 3, 1 dash 2 dash 3 dash, and draw lines joining 1 dash to C, 2 dash to C, everything. Okay, take a line and from C connect this one, connect this one. Nice. And now draw lines from D. The same we saw in the rectangular method also, the similarly. Now we have to connect this one to intersect the C1 dash and this line 2 dash to C2 dash. In the previous video also we saw using the extend command EX. Perfect. It intersects at 1 and 1 dash. 2 and 2 dash not intersected. Once again. Yes. Now it was perfectly intersected. That's it. After this one, mark the intersection points as P1, P2, P3. What I am going to do? Empty M text, capital P1, 1 should be the suffix. Okay, let be as 3. CO copy. I am going for multiple mode. Please switch off the ortho, and then this is the point P1 and this is the point P2. Let me rename this one for your understanding too. Select this one, suffix. Nice. If at all you want to intersect, mark the points, PO, mark it. PO, mark it. Nice. So in this parallelogram, the quarter part we finished it. The quarter part we finished it. In the previous method, rectangle, first we marked the points for the quarter and then we used mirror for the another one. But this is a parallelogram. Here we should not do any mirror. Always we need to construct the similar procedure. Okay, mirror doesn't works here. Now the quarter part finished. Next, repeat steps 3 to 9 on OB and BF. On OB and BF we need to follow the same procedure. Means div, select this one, 3 parts, select this parts, 3 parts. Sorry, actually it's a single entity. I need to break it. BR, bracket point, perfect. div, nice. Number of segments as 3, perfectly finished. Now once again, let us join these lines. Let us join these lines, and from here to here and from here to here. Okay, dt, this one I am taking it as 3 and this one I am taking it as 4. This one as 4 dash and this one as 3 dash. Now EX, extend, perfect, perfect. So 4 dash got extended here, 3 dash got extended to here. Now again Control C, Control V, Control V, P3, P4, perfect. Now we form this one. You can see that the same. Repeat steps 3 to 9 on OB and BF sides for the other quarter of the ellipse. So this one quarter, second quarter got finished. And now what we have to do is that using the spline command SPL, start with A, P1, P2, C, this one as P3 and this one as P4 and up to B. Just if I want to mark PO, let us mark here. Same PO, let me mark here. Nice. let me take some line weight and color. Okay, nice, perfectly. Now we got the half part of the ellipse. Similarly, if you want to follow here, it takes much time. So instead of, to avoid this one, what I am doing, copy and rotate the half spline curve for 180 degrees. You can see what I am going to do. I am just selecting this object, rotate, RO, enter, specify base point, this one. I am going with this base point. Click on please copy. I clicked on copy, rotation angle is 180 degrees. Finished, see. Now select this point, move, M for move, select, and this as the base point, please get it here and then keep it. Now successfully we completed the ellipse in a parallelogram. So this is how you can construct an ellipse in a parallelogram. And now the main concept is, one more main concept is that how to draw a tangent and normal to the ellipse, especially in the parallelogram. Why? Because I said that this AB and CD are not the major axis and minor axis. These are just a conjugate diameters, just conjugate diameters. To draw a tangent and normal to the ellipse, must and should you require major and minor axis. How come you are saying that major and minor axis, sir? Yes, you can see guys, when the angle between the axes is not 90 degrees, then these are called as conjugate diameters. But whenever I need the major and minor, the angle between them always should be 90 degrees. Always it should be 90 degrees. So that's why first let's construct or find out the major and minor axis, then we will draw the tangent and normal to the ellipse. How to find the major and minor axis for the ellipse in a parallelogram method? First, let's see. With O as center and OC as radius, draw a circle intersecting the ellipse at point Q. Okay, what they are saying, take the circle command and with O as center and OC as radius. See, this is the radius OC. We constructed a circle where the point is intersecting, this circle is intersecting at this point or at this point. Only at 2 points it is intersecting the circle. So that's why what I am going to do here is, before going to the market, let us change some color so that there will be differentiation. I mark this one C. Okay, first we will give the marking. These are the intersection point. Okay, DT. Let me change this point as Q. Nice. Now take a line, join C and Q. Perfect. You can see guys, join C and Q. Nice. Okay. Now what they are saying, draw a line FG parallel to CQ passing through center O. You can see that already this is a CQ line. I need to draw a line parallel to CQ. FG means from here. Of course, notations are wrong. FG parallel to CQ. Already I gave the FG. Any other notations you can take it out. Okay, not an issue with the notations. So now I need to draw a line parallel to this one. It should pass through center O. Instead of going for offset, what I am going to do is that please select this one. CO, copy, enter. CO, copy, enter, and please check this as a base point and then this as the destination point, second point. Please click here. I just copied this CQ line and it should be parallel to CQ and it should pass through O. That's why I copied and kept here. Now what I am going to do is that EX, extend, enter, click on this one, till it reaches the ellipse. In the similar way, on the other side also, you please do it. Perfect. Now see, this is the major axis of the ellipse. This is the major axis of the ellipse. Now what they are saying, draw a line perpendicular to FG passing through center O is the actually draw a line FG parallel to CQ through center O. This is the major axis and this is the minor axis. While copying it, done. Now for perpendicular to this one, what I am going to do, rotate, specify base point, please press on copy, 90 degrees. See, this is the minor axis. So please trim the unnecessary portion. That's it. Similarly, I can trim here also. Nice. Now this is the major axis and this is the minor axis. Now you can ask me, sir, how come you are saying again it's a major axis and minor axis? Let us check the dimension, DAN, angular dimension, DAN, and find out the angle between the major and minor. See, exactly 90 degrees I got. But whereas this conjugate diameter AB and CD, we got it as 75 degrees. If you want to check DAN, dimension angular, see, that's the difference. We should not draw tangent and normal to for the conjugate diameters, major axis and minor axis only. Okay, let me delete this one because it will be confusion for you to draw the tangent and normal. Nice. And now mark a point P on the ellipse at any point. Just a minute, it got stuck. So this is how we can draw it. In the previous method, a rectangle also, the same procedure only. Yeah. Now what I am going to do is that let me take any other color. Okay, this time I will go with the bilayer only. We'll see. PO, I want at this point. Control C, Control V. Done. So now I want my tangent and normal at this point. Similar to the rectangular method, how we draw, the same we have to follow. So now what I am going to do, I am going to draw a circle with this center and major axis as diameter. Major axis, not the previous conjugate, the freshly and newly just recently find out major axis. Yes, see, perfect. This is the circle and this is the point. And from this point, I need to draw a line parallel to minor axis. I need to draw a line parallel to minor axis. What I am going to do, just select this one. Instead of drawing the line CO, copy. This is a base point. I am just keeping it here. Because I need to draw a parallel line. Instead of drawing a line perfectly, I just copied and kept it here. Trim, TR. I don't want this portion. That's it. Perfect. Now let me mark this point as something. Okay. I mark this point. Actually it's not Q. I just copied. From P, draw a line parallel to minor axis. Cutting at, I can take it as S. Okay. Let me take S here. Yeah. So now Control C, Control V, similar to the rectangular method. Yes, nice. And now what we did in rectangular method, at this point I drawn a line tangentially. The tangential line should meet the extended major axis line. So before going to draw this one, let me draw a extended major axis line. See, a green color line appears that yes, it is in the same direction. If you move, it won't. Yes, now it's perfect. Extended major axis in the same direction. Now let's go with the line tangential at point S. Take the line, enter, TAN, tangential, enter. Specify first point. Zoom it and then exactly mark this point. Okay, nice. Sometimes if you zoom in more, it will create a problem. Okay, once again, line L, TAN, tangential. Just selected this point. See, once again you cross check and you will have an idea which one is perfectly tangential. See, again whenever I zoomed, the line is missing. Once again please, L, TAN, tangential, and select this line. Yes, click it here. It is tangential to this point. Okay, and now trim this portion. Control C, Control V. This point as T. And now through T, I am drawing a line P, and in the same direction I am just keeping it here. So this is the T dash. Control C, Control V. This is the tangential point, and we draw a tangent TT dash and select this one, rotate, specify base point, click on copy, 90 degrees. This is a normal line. It's very big, no need such a long. In the same direction, reduce it. Change the color to any other. Yeah. Control C, Control V. N dash N. This is unnecessary. TR. That's it. This is how you can draw a ellipse in a parallelogram. See, already these dimensions are mandatory. Without dimensions, don't submit any drawing. Please mark all the dimensions and notations. Perfectly, we constructed ellipse in a parallelogram as well as tangent and normal to the ellipse also. So the next video will be on ellipse on arcs of circles or intersection of arcs method.